Okay, before we start, I just want to confirm that you guys can hear me. Please type in the chat if you guys can hear me. Okay, perfect. On YouTube, you guys can hear me fine. Okay, cool. So, assalamu alaikum and good morning. Welcome to everyone. Welcome to the inaugural lesson for grade 9 mathematics. My name is Abdullah Ali, and I'm going to be your guys' tutor for this year. All right. So, for today, we're going to be starting with whole numbers. Okay. If you guys do have any questions during the lesson, please feel free to put your question in the chat, or you can make use of the Q&A feature, whichever one you prefer. Just so, yeah, then you can ask your questions via there. Okay, cool. So let's get started. Okay, so what we're going to do is we're going to start off with some basic revision of numbers. Okay, so we are going to distinguish between non-real numbers and real numbers. Okay, so we're going to first start off with non-real numbers. So we define non-real numbers as any number, okay, that is a negative inside of a third. Any number that's a negative inside of a third, or we could even say less than 0. We could describe it as less than 0. So for example, if we have a third like -7, this is a type of number that we would describe as a non-real number. Okay, so another example could be square root -21, for example. Okay, again, a non-real number. Whenever we have a negative inside of our third, that gives us a non-real number. A real number is basically whenever we have a number inside of a third that's greater than or equal to 0, we would refer to that as a real number. Okay, so non-real number inside of a third less than 0, a real number inside of a third greater than or equal to 0. Okay, then we're going to further distinguish real numbers. So as you can see this box, non-real numbers ends there, but however, with real numbers, we have to distinguish further. So 1 second, sorry. Okay, so we further distinguish our real numbers into rational and irrational numbers. Okay, so let us first discuss irrational numbers. So irrational numbers, we can see that some examples are pi and √2. Okay, so pi, okay, normally we just learn it as 3,14, but if you have to input pi into your calculator, you will get a value of 3.141592654 ... So that number goes on till infinity, right? And so too, if you do the same for √2, you're going to get 1.414 ... So basically the decimals are endless. Okay, so with these type of numbers, they are non-terminating decimals. The decimals don't end. We are unable to actually, we don't know its entire value. And that's what we would refer to as an irrational number. Okay, when we don't know basically the entire value of it, when it has decimals continuing on forever. Okay, those are irrational. When we talk about rational numbers, we talk about numbers that we do know the entire value of. Let's just say, for example, 2 or 0.6, okay, which could also be written as 3/5. Both of these, okay, they're the same thing, but these are rational numbers, meaning we know the entire value of 2. Okay, it doesn't have never-ending decimals. We know the entire value of 0.6. There's nothing more to it, right? And for example, 20.5 as well. Okay, that's another decimal number that we know the entire value of, and that's what we would define as a rational number. Okay, so non-real and real numbers we've distinguished between. Non-real is inside of a third less than 0. Real is inside of a third greater than or equal to 0. Within real numbers, we have rational and irrational. With irrational, we said that they are never-ending decimals that we don't know the value of. And with rational, we said we know the entire value of them. Now, within rational numbers, we further differentiate them as integers, whole numbers, and natural numbers. Okay, so we can start from the bottom with natural numbers. Now, natural numbers are the natural way in which we count. Okay, so 1, 2, 3, 4, 5, 6. And whole numbers are all the natural numbers, but including 0. Okay, so natural numbers, natural way we count, whole numbers, 0, and the natural numbers as well. And then integers are positive and negative whole numbers. So the integers include our negative numbers. So -3, -2, -1, 0, 1, 2, 3, and going both sides. Okay, so that's what we would refer to as integers. Okay, cool. So that's the basic, the revision of the basics of numbers. Okay, let's move on. So we're going to move on to prime factors. Okay, and writing numbers as the product of their prime factors. Okay, so firstly, we're going to revise the definition of prime numbers, which I expect you learned in grade 8. Okay, so we're just going to revise the definition. A prime number, okay, is a number that has only two factors, one and itself. Okay, so remember, let's just revise one more time. What is a factor? Okay, a factor is a number that can go into another number an exact amount of times. So let's look at the number 24, for example, right? If we have to discuss the number 24 and we want to talk about its factors, we have to talk about numbers that can go exactly into it. So if we look at the number 10, 10 cannot go an exact amount of times into 24. So therefore, it's not a factor of 24. When we talk about the factors of 24, we say 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay, so all of these numbers are factors of 24. They go an exact amount of times into 24. Okay, so now when we talk about prime numbers are numbers that have only two factors, one and itself. Okay, and if we look at our examples of our prime numbers, the first few prime numbers, you can see 2, 3, 5, 7, 11, 13. Let's think of 7, for example. There's no other number that can go into 7 except 1 and 7. Okay, and so it's the same for the rest of these numbers, right? So prime numbers, you should know at least like the first 10. Okay, and then yeah, that should be helpful, especially for product of prime factors. Okay, then they have an example. Example 17 is a prime since it's only two factors are 1 and 17. Then we have the definition for composite number. A composite number has more than two factors. So a composite number is basically all the numbers that are not prime numbers are composite numbers. Okay, they have more than two factors. Okay, now let's look at product of prime factors, right? Which for the most part till HCF and LCM should be revision from grade 8, right? So when we're writing something as a product of its prime factors, we actually utilize the ladder method. So we write out the number and we draw a ladder as such. Okay, so essentially what we are going to do is we are going to constantly divide our number on the left, this number here, by a prime number. The only numbers that go on the right are prime numbers. We constantly divide 24 or whatever number is on the left by a prime number. Now, you can go for the biggest prime number possible that goes into 24, or alternatively, you can always start with the smaller ones and eventually you will get you will write it out as a product of its prime factors, right? So right now, we can even go for 2, we can go for 3, okay? So if it's an even number, you generally want to do 2 to split it in half, to split it in half, to split it in half as much as you can, right? So I'm going to divide it by 2. And when I divide 24 by 2, I am left with 12. So I write down 12 on the left-hand side. Okay, again, on the right-hand side, I'm only going to be dividing by prime numbers. So which number am I dividing? I'm going to divide 12 by another prime number. 2 can go into 12 again. So I write it again. When I divide 12 by 2, I'm left with 6. I need to divide by another prime number. I can divide by 2 again because it's an even number. When I divide 6 by 2, I'm left with 3. And now the prime number that I can divide 3 by is actually itself, because 3 itself is a prime number. So I put down 3. When I divide 3 by 3, I'm left with 1, and then we are done. Okay, so this here is using the ladder method to write 24 as a product of its prime factors. Okay, so we basically now have its prime factors. It is all of these values here. So what we need to do is we need to multiply all of these values. So we can say 2 times 2 times 2 times 3. Okay, if you do this calculation, you will get 24. And it's a product. A product of its prime factors, right? Okay. I just want to confirm that you guys can still hear me and we're still going. We're still up and running. Okay, cool. Thanks. Okay. Okay, so now we can also write this in exponential form. Okay, so we just basically can group these 3 2's. There's going to be 2 to the power of 3 times 3. Okay, and this is 24 written as a product of its prime factors. Okay, let's look at what's this, 45. Okay, let's look at 45, and we're going to utilize the same ladder method. So we need to divide 45 by the highest prime number or any prime number, even if it's the lowest. It doesn't really matter because eventually you will get through all of the prime numbers. Okay, so maybe 3 or 5. I think 5 is easier. So I divide it by 5. When I divide 45 by 5, I'm left with 9. A prime number that can go into 9, I would say 3. When I divide 9 by 3, I'm left with 3. A prime number that can go into 3, that would be 3. And finally, I'm left with 1. So then I'm done. So now I have written 45 as a product of its prime factors. Right? So I can write it as 5 times 3 times 3, or 3 to the power of 2 times 5. This is what 45 is equal to. Okay, let's do this last one, 500. Again, ladder method. So this is a big number, okay, but it's an even number. So the easiest thing that we can do is divide it by 2. Okay, we don't have to always go for the biggest one. We could even divide it by 5 in this case, but let's do 2, all right? 5 would technically be easier, but it's fine. Let's do 2. When I divide 500 by 2, I'm left with 250. When I can divide 250 by 2 again, because it's an even number. When I divide it by 2, I'm left with 125. 125 is an odd number, so I cannot divide it by 2 anymore. I now have to choose either like 3, 5, 7, and the obvious one is 5. When I divide 125 by 5, I'm left with 25. Okay. When I prime number that can go into 25, that would be 5 again. When I divide 25 by 5, I'm left with 5. And the prime number that can go into 5 is 5 itself, and I'm left with 1. And we are done. So I'm going to write this as 2 times 2 times 3 5s, right? And therefore 500 is equal to 2 squared times 5 cubed. Okay, cool. So that's product of prime factors. Let's talk about HCF and LCM. So HCF and LCM, remember HCF is our highest common factor and LCM is lowest common multiple. So we have steps to calculate the HCF. So let's follow them. So the first is, in order to calculate the HCF between 2 or more numbers, firstly, you have to do the prime factorization of each number, which we just revised, right? You have to identify the common factors and multiply the common factors only on one side. Okay, we'll get to that, right? So let's look at these two numbers. We have 36 and we have 68. So the first step says, they said, use the prime factors to find the HCF and LCM of 36 and 68. So the first step is to write the number, do the prime factorization of each number. So this I'm going to divide by 2. I'm left with 18. I'm going to divide by 2 again. I'm left with 9. I'm going to divide by 3. I'm left with 3. and I'm going to divide by 3 again, and I'm left with 1. Okay, so prime factorization done. Let's do 68. Okay, so I can divide 68 by 2, and I get 34. I can divide 34 by 2, and I get 17. Now 17, I can't divide by 2, that's an odd number. Let's go see if there's any. Okay, 17 itself is a prime number, so of course it's not going to have any factors besides 1 in itself. So the prime number that I can divide 17 by is actually itself, and I'm left with 1. Okay, let me just copy this for LCM. Okay, so firstly we're going to do HCF, right? Now, HCF says identify the common factors and multiply the common factors only on one side. So basically what you have to do is anything that's common, you need to identify it in both prime factorization sets. So for example, if I look at my first prime factor of 36, it's a 2, and I notice that there is a 2 on the other side as well. Okay, so that's common. That's what we mean when we say common, right? Then I notice that there's another 2 and another 2 that's common. Okay, but as soon as I go to the 3, there's no 3 this side, so that's not common. Okay, so that's essentially what they're saying. Identify the common factors, ones that are common. So what you need to do is, if you have a 2 here and a 2 on the other side, you can highlight it or circle it. And then if you have any pairs that are matching, you just highlight it on one factorization set. You take those numbers that are highlighted and you multiply them. So I'm only going to take these 2. So I'm going to say 2 times 2. And this is going to give me the HCF of 4. The highest common factor between 36 and 68 is actually 4. Okay, so one more time. You need to identify the common factors and multiply the common factors only on one side. So I've identified them. It's 2 because it's common there. There's another 2 because it's common there. There's no 3 on both sides, and there's no 17 on both sides. It's only on 1, respectively, right? Okay, so that's the HCF done, right? For 2 numbers. Let's look at LCM. What are the steps for LCM? Okay, so the LCM, the lowest common multiple, says that your first step is to write out the prime factorization of each number, write each factor in exponent notation. Okay, we went through that earlier, and multiply each factor with its highest power. Okay, so let's do that so that it makes more sense. So it wants us to, the rule says we need to write it out in exponent notation. So I'm going to say 2 squared times 3 squared. Then I'm going to say 2 squared times 17. Okay, so that's in exponent notation. Multiply each factor with its highest power. So what that basically means is you're going to look at all your factors. Okay, within my factors, I have a 2, I have a 3, and I have 17. Okay, yes, I have a 2 there as well, but I'm looking for each individual number. I have a 2, I have a 3, I have 17. I am going to identify the highest power of each number, and I'm going to multiply those out. Okay, so for example, 2, its highest power is a square. So I take the square. Let's look at 3. 3, its highest power is a square. So I take the square. And 17, its highest power is a 1. So I take it. I take all the numbers, okay, within my factors, I take all the numbers, and I select the number with the highest power, and I multiply them. And that's going to give me my LCM. So when I multiply this out, 2 squared times 3 squared times 17, I get the highest common multiple as 612. Okay. So that's for 2 numbers. HCF, okay. So for HCF and LCM, each of them, you need to write out the prime factorization of each. For HCF, you need to identify the common factors and multiply it only on one set of prime factors. Then for lowest common multiple, you need to write out your factors in exponent notation and select each number with the highest power, multiply it out, and you'll get your lowest common multiple. Let's look at the next set. We have 3 digits, 3 numbers. We have 24, we have 28, and we have 42. So again, first step, prime factorization of each. Okay, so 24, I'm going to start off and I'm going to divide it by 2. When I divide it by 2, I get 12, 6, 3. I can divide it by 2 one more time, another time, and that's the last time. I need to divide this by 3, and I'm left with 1. Divide by 2, 6, divide by 2, 3, divide by 3, 1, and we're done. And we're going to do 28. Okay, so 28 I can divide by 2 as well. I'm left with 14, which I can also divide by 2, and I'm left with 7, which I can then divide by itself because 7 is actually a prime number, and I'm left with 1. Then I can do 42. So 42, of course, I can divide by 2. I'm left with 21, which I cannot divide by 2. However, I can actually divide it by 7, which is a prime number. I'm left with 3, and I can divide 3 by itself to give me 1, and we are done. Let's just copy this for LCM. Okay, so for HCF, right, we have to identify the common factors. But now, when we're dealing with 3 numbers, it actually has to be common in all 3. Okay, not just 2 of them, or any 2, or the first 2, or the last 2, or the first and last. It has to be common in all 3. So let's look at this first 2. Do I have a 2 in the second and third sets? Yes, I do. So I can highlight this 2. All right, remember, we only identify that common factor, like we only utilize the number from one prime set of factors, but they have to be common in all 3. Then I look at the second 2. Is there a second 2? Sorry, is there a 2 in the second and third sets? There is in the second, but not in the third. So I can't. That's another 2, so it's not going to work. There's a 3 here. Is there a 3 in this set? No, there isn't. So the 2 is there's only one 2 that is common in all 3. And that is that's what I would identify as the common factor, again, in all 3. Okay, so remember, you take your common factors and you multiply them. In this case, it's only 2. So therefore, my HCF is actually just 2. Okay, let's move on to LCM. So remember, with LCM, you have to do the prime factorization, which is done. You thereafter have to write it in exponent notation. Exponent notation, this would be 2 cubed times 3. This would be 2 squared times 7. This would be 2 times 7 times 3. So we have 3 numbers. We have a 2, we have a 3, we have a 7 within our factors. Our job is to identify the factor or the number with the highest power. So for 2, that would be 2 cubed. For 3, it would just be 3. And for 7, it would just be 7 to the power of 1. Okay, the highest overall. So in order to get our LCM, we would say 2 to the power of 3 times 3 times 7. When I do the calculation, I should get 2 to the power of 3 times 3 times 7, 168. So my lowest common multiple is 168. Okay, cool. So that's 2 numbers and 3 numbers, HCF and LCM, done. Okay. Let's move on to ratio. Okay, again, revision of grade 8 for the most part, but it's compulsory for your year as well. Okay, so the first thing we're going to talk about is ratio. A ratio is a way of comparing 2 quantities that are the same. Okay, comparing and simplifying ratios, ensure all units are the same, or that all fractions have a LCD. Divide each part of the ratio by the largest number that's still leaves the answer with whole numbers. Okay, so let's go and do a few examples. That's the best way to practice. Let's move this guy out of the way. So they want us to basically simplify the following ratios, okay? So this is just simplifying ratios. So if we have a look at the first one, we have R2.20 and 60 cents. Now, of course, they are different units and we cannot compare different units. So that was what they mentioned here. Ensure that all units are the same. In order to compare it, it was also part of the first thing. It says that two quantities that are the same. So they have to be the same unit in order for us to compare their ratios in order for it to be fair, right? So what we have to do here is actually convert them to the same thing. I have a table of common conversions, mainly for like units of measuring, like grams, milligrams, milliliters, meters, whatever it is, right? You can go through these. It's important to know those, right? Okay, so what we're going to do is we're going to convert, let's convert the rands to cents, right? That will be a bit easier, so we don't have to deal with our decimals. So remember, we have 1 rand equals 100 cents. So basically, we've got to multiply this by 100. Okay, because each rand has 100 cents. Here we have 2 rands and 20 cents. So we say 2.2, we're going to multiply it by 100, and that's going to give us 220 cents. And now we can compare it to our 60 cents. Okay, so when it comes to simplifying ratios, right, again, you don't actually have to get the answer directly. So like you might think you need to find the HCF, the highest common factor, but you can get any factor that works and then continue going down and down and down. For example, here we can use 2, okay, even to just simplify it once. Instead of getting the answer one shot, we can use 2, all right? Alternatively, you could use your calculator and say 220 over 60. That would give you the answer directly, right? So we can divide by 2, we'll get 30 is to 110. Here we can divide each by 10, or even there we could have divided by 10, but it's fine. Here we divide by 10, we get 10, we get 3 and 11. So and this is the simplified ratio, because both of these numbers, I believe, are prime numbers either way. Yeah. So nothing can go into those. So that's the simplest ratio there. Okay. This example, let's go through it as well. 5.2 liters to 600 milliliters. So let's convert the 5.2 liters to milliliters. 5.2 liters, 1 liter is 1,000 milliliters. So again, we multiply this guy by 1,000. We get 5,200 milliliters is to 600 milliliters. So I'm going to choose to divide them both by 100. I'm going to get 6 is to 52. I can still simplify that by dividing by 2. And I get 3, of course, and 26. Okay, so simplifying ratios, it's quite simple, no pun intended. Okay, determine the ratio of lengths AB to AC to BC in its simplest form. Okay, same thing. I'm going to do this quickly. So AB is 12, AC is 16, BC is 20, and then you just need to simplify it, right? With 3 ratios, it's the same thing. So I can divide these all by 4, I believe. So it's 5 is to 4 is to 3. Okay, cool. Let's move on. Let's talk about increasing or decreasing a ratio, increasing or decreasing in a given ratio. Okay, so we have 2 simple rules that you need to follow that are the key to answering these questions. So the first one is when increasing in a given ratio, the numerator needs to be bigger than the denominator. Okay, and then it says when decreasing in a given ratio, the numerator needs to be smaller than the denominator. Okay, so basically all that means is you need to remember the keywords. Increasing, numerator is bigger. Decreasing, numerator is smaller. Or denominator is bigger, whichever one you want, however you want to remember it. But yeah, what that means is you get a question like this that says increase 100 rand in the ratio 5 is to 4. So you are actually going to multiply it by the ratio. Okay, remember ratios can always be written as fractions, and that's why it says here when increasing, in a given ratio, the numerator needs to be bigger than the denominator. So here my bigger number is 5. So I'm going to say 100 times, because I'm increasing, my numerator needs to be bigger. I'm going to say 100 times 5/4. And basically, I will get the correct answer. If I do that calculation, I'll get 125. And that will be the answer for 100 increased in the ratio 5:4. Let's talk about decreasing 240 milliliters in the ratio 3:8. So remember what we said about decreasing. When decreasing in a given ratio, the numerator needs to be smaller than the denominator. My smaller number is 3. So I'm going to multiply this value by 3/8 and not 8/3, so that I can decrease the ratio. When I decrease the ratio and I do the calculation, I get an answer of 90 milliliters as 240 decreased in the ratio 3:8. Okay, cool. Hope that makes sense. Okay, now let us talk about ratio and sharing. If sweets are shared between you and your friend in the ratio 2:3, it means that for every 2 sweets that you get, your friend has 3. Okay, so the total shared is 5. 2 plus 3 = 5 parts. Okay, so this is important to understand when you are sharing ratios. Yes, it's the concept of when you have a ratio of 2:3, for every 2 parts, the other person has 3 parts. So literally for every 2 sweets, you have 3. For every 4, they have 6. For every 6, they have 8. No, 9. Okay, so that's what the ratio follows. So this says divide 30 sweets between Thabo and Jenny in the ratio 2:3. Okay, so how do we do this? Okay, the first step is to take your ratios. Remember, you need to separate this into 2 parts and 3 parts. So if we consider in total, we actually have 5 parts. Okay, 5 parts total. 2 of them went to yourself. Okay, in this case, 2 of them went to Thabo, and 3 of them went to Jenny. Okay, so we're going to divide these 30 sweets between these 2 people in the ratio 2:3. One more time, we have 5 parts total because 2 plus 3. So we always want to add our ratio because that is the total amount of parts we're actually going to break up those 30 sweets in. Thereafter, what we do, since we know the total amount of parts, okay, so remember, whenever you're working in maths or physics, they'll generally use the word respectively. But if a ratio is mentioned like 2:3 and names are mentioned, know that the first name is for the first ratio and the second name is for the second ratio. It's not just for ratios. It's for anything when they're mentioning people and numbers or anything and numbers, all right? So in that case, we know that Thabo is going to get the ratio of 2. Now, so for Thabo, okay, so his part is 2 out of the total 5 parts. So what we do is we create a fraction 2/5. Okay, because out of the total 5 parts, Thabo is going to get 2. We take that fraction and we multiply it by our total amount of sweets. Okay, and we get our final answer. We know that Thabo has 12 sweets. Then for Jenny, we know that her parts are 3 out of the total 5 that's available, multiplied by the total amount of sweets, and we get, of course, 18 sweets for Jenny. And that's done. You can, of course, check your answer by adding these 2 up, and they will add up to 30 total. Okay, so that's sharing ratios, 2:3 ratio. Let's look at one with 3. Share 69 apples between horses, pigs, and goats on a farm in the ratio 15:5:3. Same concept. 15 plus 5 plus 3. So 15 parts, 5 parts, 3 parts. When we add them all together, we get 23 total parts. Overall, we have 23 parts. So for the horses, okay, same concept applies here, by the way. Horses would be 15. Those would be 5. goats would be 3. So for the horses, we're going to take their ratio over the total parts available multiplied by the total amount of apples available. And we get an answer of 45 apples. Then we're going to look at pigs. We have 5, their ratio over the total amount of parts available, which is 23, times it by the total. We are going to get an answer of 15 apples. Okay, just a side note as well, guys. You are free to take notes during this lesson, of course. These notes will, however, be sent to you at the end of the lesson, latest by the night of each lesson. You will be getting these notes in the group. Okay, then we can do the goats. Finally, the A ratio is 3 over 23 times the total amount. That gives us 9 apples. Okay, done. We shared the apples in the ratio of 15, 5, and 3. Okay, let's look at this question. Maybe slightly more complex. It says in a bag of marbles, there are blue and pink marbles in the ratio 2:7. If there are 16 blue marbles, how many marbles are there in total? What if all the numbers were the same? What do you mean, what if all the numbers are the same, like the ratios? If the ratios are the same and it's a number that can go, exactly into the total number, then each person is going to get the same amount of apples. If you're sharing it into a 1:1:1 ratio, essentially. And then you're basically splitting it 3 ways. It's like you can divide the total number by 3, and then each person would get whatever that amount is, either way. Okay, let me just see what else we have to go. We end in 13 minutes. Okay, I'll just do this question. Okay, in a bag of marbles, right, there are blue and pink marbles in the ratio 2:7. Okay, again, don't forget that concept. If there are 16 blue marbles, how many marbles are there in total? Okay, so this question is kind of like backwards, where you have information about the amount of one marble, and we know how many blue marbles there are, we don't know how many pink marbles there are, and we don't know the total. Okay, so in this case, we need to work with fractions. As you can see, the note says fractions are a common way of writing ratios. Okay, so here we have blue marbles is to pink marbles, okay, as a 2:7 ratio. So a 2:7 ratio, we can actually represent as a fraction. So blue over pink is going to be equal to 2/7. Now, remember 2/7 is this, 2/7 is the simplified ratio, okay? So 2/7 is the simplified ratio. So actually the 2/7 is the ratio, okay, just written as a fraction, okay? So we can actually equate this to another fraction with the actual amount of blue marbles. Because we know that there are actually 16 blue marbles, we need to know that those 16 blue marbles are actually part of the ratio 2. So it's 16. The 16 goes on top, okay? The 16 is the basically like the 2 ratio part, okay? And the unknown pink marbles we can call P. So 2/7 is the ratio of blue to pink marbles, okay? And 16 over an unknown amount of pink marbles it has to follow the ratio because they tell us that it's split in the 2:7 ratio. So now that we've identified this equation, that 2/7 is equal to 16 over P, we can do algebra, okay? Solving for this variable, solving for this unknown, we can cross multiply and solve. So I'm going to get 2P is equal to 16 times 7, 112. P is equal to 112 divided by 2. I divide both sides by 2. And I get P is equal to 56 marbles. So when there are 16 blue marbles, there are 56 pink marbles. Okay, the question was how many marbles are there in total? So we're going to say blue plus pink, which is 16 plus 56, and that's going to give us a total of 72 marbles. Okay, so important here is to understand fractions. Okay, and our fractions are a great way of expressing ratios, especially when it comes to doing calculations. Okay, let's look at something like rate. Okay, so rate is a bit more, there's not so much method to rate. Okay. Nevertheless, let's go through it, right? Okay, so rate is a way of comparing two different quantities. So a simple example of rate is actually the speed of a car. Okay, a lot of the times we describe the speed of a car as 56 kilometers per hour, 120 kilometers per hour. Okay, so we are describing we are basically comparing two different quantities: kilometers, which is distance, and hours, which is time. Okay, and that can be that is seen a lot in a lot of different examples, right? So express each of these as a rate. Firstly, it's the 5 kg of chicken for 179.99. So in this case, okay, we can now, if they want us to express it as a rate, we can basically try and figure out how much would the chicken cost per kg. Okay, so in that case, we have 5 kg for 179.99. So we need to know how much did it cost per kg. So because we're getting 5 kgs for 179, we need to break down that 179 into 5 parts, 5 equal parts, so we know how much 1 kg costed. Okay, so in that case, we need to do division. We need to take the 179 and divide it into 5 parts, because this 179 is made up of the price of one kg 5 times. Okay, so when we say 179.99 divided by 5, we get an answer of, let me just double check, 179. We get an answer of 35.998, which we're just going to round off actually to 36. 36 what? Okay, so remember, here we are doing rand divided by kg. So essentially, we are working out. Okay, that's fine. Essentially, we are working out, okay, the rand per kg. So in this case, our unit is going to be 36 rand per kg. Okay, per being represented by the / or the division sign. Okay, let's look at this. If you are traveling, express this as a rate, right? Remember, they want us to express this as a rate. If you are traveling 275 kilometers in 2.5 hours, okay, here we could represent how many kilometers we are actually traveling in 1 hour. Okay, so since it's 2.5 hours, or let's call it 2.5 hours. Okay, if we want to express how many kilometers we are traveling in 1 hour, we would need to take 275 again and divide it by that 2.5. That's going to tell us exactly how much. Remember, it's kilometers per hour. Then if you want to get our average speed, basically, okay, it's going to be 110 kilometers per hour. Okay, you guys can try this example on your own time. Let's look at this, okay? A car travels at an average of 90 kilometers an hour. How far will it travel in 2 hours, 30 minutes? Okay, so I just want to remind you of this triangle. Actually, you may not have learned it. When it's distance and speed calculations. Okay, so triangle you can remember. Where distance is equal to speed times time. And then So distance here is equal to speed times time. For speed, it's going to be equal to distance over time. That's why the distance is on top, right? And then the same is for time, it's distance over speed. Okay, so in this case, a car travels an average of 90 kilometers an hour. How far will it travel in 2 hours and 30 minutes? So again, we can use our distance is equal to speed times time formula. Speed is 90 kilometers per hour. We need to ensure that our units are the same. So 90 kilometers per hour, and then this is hours as well, 2 hours, 30 minutes. So we can take our 90 and multiply it by 2.5 hours because it's 90 kilometers every hour and there's 2.5 hours. So if you're going to multiply it by the 2.5 hours, it's going to tell you, okay, in the first hour, second hour, and that last half an hour, exactly how much they traveled. When we say 90 times 2.5, we should get 130, 225. 225 kilometers. Okay, we keep the units constant. Okay, then this example you guys can try on your own. Let's look at proportion quickly. How do you turn minutes into hours? Should be here. Here we go. How do you turn minutes into hours? I have a question. How do you turn minutes into hours? So in 1 hour, there's 60 minutes. So if you want to go from minutes to hours, you need to divide by 60. Okay, what I'll do is for each, before I send it to you, I'll write it like this. Like divide, multiply to go from which one to which one. Okay, but if you want to go from hours to minutes, no, sorry, what was your question? If you want to go from minutes into hours, you need to divide by 60. Okay. Okay, whenever the number needs to get smaller. So if you're going from minutes to hours, remember there's 60 minutes in 1 hour. So if you express it as an hour, it's always going to be less. If you express it as minutes, it's always going to be more. So if you're going to go to the one that's less, which is hours, you're going to divide. And if you're going to go to minutes, if you're going to convert from hours to minutes, remember minutes are more because there's 60 minutes in 1 single hour. So whenever you're going from hours to minutes, then you're going to multiply. And it's the same for all other conversions. When you're going to the smaller one, you divide, into the bigger one, you multiply. Let's have a look at this, right? Proportionality. Okay, so we're going to discuss direct proportion and inverse proportion. So direct proportion defines as when as one quantity increases, the other does too. Okay, the more you study, the higher your mark is generally. Okay, but that is something simple that expresses a direct proportion. There is a constant ratio between the quantities, so X over Y is equal to K. Okay, what exactly does that mean? That basically means when you take the quantity of one over the other, it's going to give you a constant ratio that applies for anything. So let's look at this example. It says Tracy earns 8,100 in 4 weeks. How long should she work to earn 12,150? So in this case, we take our two separate units that we are working with. The one is money, the other one is time, 4 weeks, right? And we put them over each other to create this ratio. So 8,100 over 4. This is going to give us a constant ratio. Okay, we have to analyze the question actually first, that when you work more, you earn more. Okay, so you have to understand that concept and then tell yourself, oh, okay, this is direct proportion, because when you work more, you earn more. It doesn't work if you work less, you earn more. It doesn't work like that, right? If you work more, you're going to earn more. So if Tracy earns 8,100 in 4 weeks, we can then use the same ratio because it's a constant ratio. Okay, so we're going to put money over time. So it's 1,800 over 4, and that's going to be equal to, now she wants to earn 12,150. Okay, and we're going to divide that by, the unknown amount of weeks that she needs to work. Call that W. Okay, so here again, algebra, you're going to cross multiply. So it's going to become 12,150 times 4 is equal to 8,100 times the amount of weeks. Okay, you do this calculation and you're going to divide it by 8,100 because it's multiplied on the right. You take it over as division. And when you do that calculation, you get the weeks as 6. Okay, so that's direct proportion, and that's how you deal with it. You have to analyze the question first and make sure that you are working with direct proportion. Then you can say that you have the constant ratio. So keep whatever thingy you're working with on top. Let's just say like whatever parameter, whatever value you're working with on top, you keep them all on top. Whatever you're working with at the bottom, you keep them all at the bottom. Right, quickly, let us discuss inverse proportion. Inverse proportion is as one quantity increases, the other decreases. Many hands make light work. The more people are assigned to a certain task, the quicker it will get done. Okay, that's an example of inverse proportion. There's a constant product between the quantities. So when we multiply the quantities, we get a constant product. Basically, so let's do this example and I can show you how to do it. So it takes 6 men 2 hours to clean a yard. How long will it take 4 men to clean the yard if they work at the same pace that the 6 men work? Okay, so this is indicating inverse proportion because again, more men, less hours, less men, more hours. Okay, so I'm going to take men times hours, and it has to equal to, because the products are equal when it comes to inverse proportion. Men times hours is going to be equal to men times hours. So 6 men times 2 hours has to equal to, how long will it take 4 men times the unknown amount of hours? English call it H. So now I get 24, I get 12 is equal to 4H. I divide both sides by 4. I get 3. 3 hours. How long is it going to take 4 men working at the same pace? 3 hours. Okay, an example of inverse proportion. Okay, cool. So let's end it there. I'm going to send you guys these notes, and yeah, you guys will be able to access them on the group. I'll be communicating with you guys on the group. Cool. I will see you guys next week. Hopefully in the week, I'll try and release the timetable for you guys so you guys know which topics we are covering. Let me just check quickly what is next. I think next we're going to be working on integers. We're going to work on some finance, get to integers, and then exponents. I'm not sure. I think that's about where your actual grade 9 work starts. But cool. Thank you guys so much for joining. I hope that you guys benefited from this class and benefit from all the classes going forward. And no problem, you're welcome. I will see you guys in the next lesson. No problem. Ameen. Jazakallah khair. Assalamu alaikum. Thank you and goodbye. Thank you guys.